Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and we've done a bit of things already. We're working on operators right now. So I put off some of the function calling stuff just because I've just got to let that bubble a while, I guess. We're to the point where we have to worry about polymorphic types and how do they type match and things like that, and it's non-trivial, I guess. I decided to move back on to something else I can handle for a while, and working back in the lexical analysis for operators is pretty straightforward. So we'll start there. All right. So we left off. We're doing these multi-character tokens, so they're operators and maybe some other stuff. But we left off with dot dot, and we actually finished that last time. So we'll put that down on the done column here. And this is really dot and dot dot. Okay. We haven't used dot, but it will come up at some point. All right, and we're ready to move on to less than, or equal, and so on. I ran the tests. Everything is green. Yeah, all good. But I'm looking at this and saying, like, okay, there's some duplication again. So we did the equals last time. I think we did equals, slash, and dots. And equals, if you have one equal sign, that you come in here, you get the next character. If the next one's an equals, then it's a double equals. Otherwise, it was just an equals. Dots is very similar. Get next character. If character equals dot, then you had a dot dot, else you had a dot. Okay. And this one is somewhat similar. It's the slash. It looks for slash slash. If so, it returns int divide. Slash equals returns not equal, and a plain slash returns float divide. So it's the first two are two choice ones. This one's a three choice one, but they're very, very similar shaped, and similar enough that I want to fold them together if we can, because we got these other tokens coming in. Now we got some that are just going to be complicated. Here's the digits number ones. Digits dot, optional dot, digits, optional E, optional plus or minus, optional more digits, well, one or more digits, and that exponent is optional. That whole thing is it's a bunch of complicated things, so I don't anticipate folding it into anything. But these others, we already have a single character token. Let me go find that. Excuse me. Let's see. So, yeah, here we go. So if you have a star, that's the only, nothing else starts with star, at least as of now. And we just call single character token. I would like to do the same kind of thing for the equals case and the dot case. I don't know where the equals is. I should maybe be pulling these operators together. Let's do that. Okay, equals, slash, and dot. Okay, so I would like to generalize this thing. So let's go down there and do that. Okay, so if I do some extracting, and Swift is primitive on its refactoring, so I can't in Java say I would extract this. Actually, I would just tell this thing, hey, make this a parameter, make this a parameter, make this a parameter. But instead, I'm gonna pull them up, and then we'll extract the method. And even this, I should be able to extract to variable, but it doesn't have it. So if character equals this, well, I could say let second character equal that, and then use that. All right, that should be perfectly fine. Really? What did it just have? Equals equals cannot be applied to. Let's try of character. Excuse me. I think maybe there was some ambiguity. All right, but anyway, this thing is a constant. Nobody's referencing it, so there's completely nothing wrong with moving that up front. All right. Now, this, I want to say, let one character match equals token dot equals. Okay. Again, I don't think that's going to be a problem if I replace it here with one character match. And again, this is constant, so I'm going to move it up as well. Okay. And then same thing here. I'd like to make this the second character, I'll say token, equals token dot double equals. Move that up and use that here. Okay, I'll just move this down a touch. First character, let's rename this. First character token. Okay. Now all my tests should still pass. All right, and then I'm going to extract this method. So I did kind of an introduce parameter the old-fashioned way, I guess you'd say. You know, I moved out anything that looked like a constant that I needed to parameterize on, and now I'm going to extract method. Let's see if it will consent to that. Yes. Okay. And so this, the one was a one character token. Let's call this a two character token. Okay, and I'll format it just a little bit. And it produces token and location. Yes. Okay. That seems fine. So now I'm gonna inline this. Again, I got to do it manually. Whoops. I think, yeah, we can manually copy that. And we're looking for equals operator up here. Equals, there we go. So that was all this stuff, and we don't need this anymore. Okay. So that's, I would like I would like a different order there. Let's change the order. I want this first character token to come first. I don't know why it chose to put it last. Okay. First character token equals, second character equals, and let's find our method again. I think that might be a little better. Okay, and test. So we've inlined the equals operator. Nobody else is calling it at this point. Oh no. Two character token. Oh, I didn't. Well, he's going away anyway. All right. So this code is dead, can be gone. And we got twoCharacterToken there. Let's find where that's called again. Equals. I want to inline this stuff. So token. So you see I pulled it out as a parameter. Now I inline it back in. That's just the way of the world when you're doing it manually. I want to take the small steps that kind of keep it equal. Okay, I don't need the sidebar here. Okay. So now it is a twoCharacterToken. If you've got token.equals, if it's just the one character, you return token.equals. If the second character is equals, you return double equals. I'm okay with that. Now let's look at our dots case. Well, I don't want to spoil the surprise here, but we think this should be token.dot. If you have a second dot, token.dot. And this call should be gone. All right, so my claim is that's a refactoring because we looked at them and we decided it was the same structure, and same structure we can use the same return value. Okay, so I'm trying to make it so that the routines that the ones that really are doing the fancy lexing, they have to get their own method. But if I can do it with one method, I'd rather do that. Now this one, I want to do the same strategy basically. I want to extend this method. Well, maybe we'll put that off. It is a little more complicated case. I mean, we can do it because if we had a second character, we could, we could add an extra argument for the character in the token. All right. But I think we'll take the improvement we have. Let me just make sure that still runs. I don't think I changed anything. But gonna be careful. All right. And sorry, let me check over here. Okay. So let's commit this. Whoops. How about commit over here? Lexer, we may, well, this is a refactoring. Extract a twoCharacterToken method and use it for equals and dot. Okay. Right. All right. So now back to our to-do. So the reason I wanted to get that in first was because we have a couple more operators that need that approach. And well, these two might as well. I don't think this simple OR bar exists, nor the simple AND. Okay, and minus is a special case because minus introduces comments, so we'll have to do a little fancier method for that. These other ones, not so critical. Okay. Let's do less than and less than or equal. So Lexer and Lexer tests. Okay, and then the other thing I said I was going to do is maybe fold in some of these simple ones. Okay, so let's move this down with kind of where it fit the other one. Right in here. The other operators. But I think we can say let's say test simple test simple tokens. Okay. And so I'm interested in the ones that don't really get fancy. So let's take this one. Arrow is a little fancy because of the dash thing. Left paren should be okay. Well, no, it starts operators. It's going to become more complicated in a minute. Okay, percent is okay. Star is okay. Up arrow. I think equals is all right. I don't mind the 2-character ones. Oh, maybe these are 1-character tokens. Is that more interesting? 1-character tokens. I don't know what I did there. There's my equals, double equals, float divide is simple enough. I'll separate these by their pairs, possibly triples. Float divide, int divide. I don't see not equals. Not equals is not in here. Okay, these are all dead. All right. All right, these are tests we had. All right, but I do think there's supposed to be a check token / equals token dot not equal. Missing test. Okay. Reorganize tests and missing test for not equal. All right. So I think we're ready to move on to less than, token dot less than, and less or equal. Okay, and does that exist? Nope. Okay. See if I spelled them consistently. Yes. Okay. So this test should fail both those lines. Okay, and both cases are going to be errors by default. Okay. So in our lexer, we just had to look for them. And it's a lot like this case. So case less than, return a 2-character token. We can have token.less than. Second character is equal. If we see that, we get token.less than or equal. Okay, and I think that should pass. So you can see right away this refactoring is paying off already. I don't know. We've probably spent a little more, but our next token, let's see, we did this one. Next one's greater than. Okay, so this is 2021. I'm not on the right year still. The story, we're just calling it operators. There's a little more to it, but that's okay. Multi-character tokens. All right. Let's fix that while we're here. How long have I been doing this? Usually by February I'm kind of caught up, but okay. Yeah. Looks like I had a relapse. Okay. So we got less than or equal. We want to do greater, or equal. And we're not quite at a parameterized level, but you can see we'd almost be there. I probably should at some point. Okay, so no member. All right, test fails. I'll trust that it was for the, well, a better look. Yeah. So that error is our sort of default case, is like if you don't tell me something I know how to deal with, I assume there was an error. We got token dot greater than. If your second character is equal, you are token dot greater than or equal. It should pass. All right. Okay, so next, well, let's check that in. Tokens only. Okay, we're not parsing anything with them. We're just doing it. Okay. Now plus and plus plus, I think that's the same. I don't think we handle it yet. Okay. And I'm not sure a good order. Oh, interesting. One test failed. No. I guess one test function failed, but with 2 assertion failures in it, right? Yeah. Okay. I'm gonna take this one. We'll have to figure out the order at some point. I don't know. I may fold this all into a big function or something yet. We'll see. Let's see. plus twoCharacter is plus, and if you see a second plus, you get plus plus. All right, I guess our to-do. Now this one, it's interesting because basically I want to make single plus or single ampersand be an error. All right, so let's put that in the tests. All right, so a single ampersand is an error. Oops, and a second ampersand is I guess I've been doing this. So this is token.error. Unknown expected token. Okay. Should fail. The first one should pass, actually. 185 by accident, as it were. Unexpected character in input is not equal to unexpected character. Okay, well, let's find the message. It's our get default token. Oh, let's use the official one. Okay. There may be some others that change now. I would imagine there's going to be at least a few. All right. And let's find that other. That's this one, the one we expect. Then there's one up here. We'll just choose error messages. Okay, I think we're down to the one failing we expect. And it's a little diverted. I'm checking a case, wasn't a perfectly clean change, I guess you'd say. But we're ready to implement this one. So if you see an ampersand, the first token is token.error with the message error messages.unexpected token. The second one is the second ampersand, in which case we expect token.ampersand. And just to kind of clean up the formatting a little bit here, when they get ugly, I break them up one line per parameter. Okay. We got that. That should be okay. Okay. Is not error unexpected character in input. Huh. Oh. probably helps to do that. Keep changing my wording, but maybe this is a better one. And double ampersand. Okay. And then, so we got that one. Let's do the double bar. Well, I haven't done it yet. Okay. I'm going to move these up. Oh, our less than's definitely are getting complicated, aren't they? Actually, it's making everything complicated. So this is less than. We got pipe bar or bar greater, less than pipe, less than, and greater, which we haven't handled. All right, so I think so I'm dealing with this case, the case like we had, like the slash, you had two alternatives. And I think that's what we're getting here, because you got bar by itself, which is an error, and then bar and bar greater. And this one, you actually have multiple alternatives, because you can have less than equal, less than pipe, less than. All right, so can I? Well, my thought is modify this. I'm thinking I'm going to modify this to become a tuple, a duple, really, two. So pair the character with the token, and then turn that into a repeat, a dot kind of thing, var args. And then we can loop through all of those extra characters and see if we find any. But the first step in that refactoring, well, I think it's doing this. I can take the names out. Or no, do I need to? What if I just do that? Is that a... Tuple cannot have two labels. I think I can name the whole tuple. Let's call it other matches. Other possibilities of that. Okay, so if I want to change that argument, now this is not second character, it's other possibilities dot 0 and other possibilities dot 1. Okay, so we're just taking the two values out of the tuple. It communicates less in some ways, but it's not bad. I mean, the character and the token do go together in a way that wasn't apparent before. So in that sense, I think it's an improvement. Now everybody who called it needs some work. Okay, so now I want them to be on the same line as a tuple. Whoops. Okay. I'll do the formatting thing again. Well, that almost fits in one, doesn't it? I'm very artificially narrow, I think. All right. We'll just format them the same. That'll help visually, right? Okay, so this. Next argument is that. And I think I'll prefer being similar more than I'm going to worry about the fact that it could fit in one line. Is that it? So let's see if that refactoring. All right, so refactor, change signature of twoCharacterTokens. Now the big move. Okay. So what I'm thinking is, if I make this, is that the var args way? No. It has no member 0. I guess this is other possibilities sub 0 dot 0 and 0 dot 1. It's kind of a halfway. But I think this is legit. We're always passing 1. I'll make it work better in a moment. Okay, so what? Right. So we somehow need to run through a loop, right? So basically, we're going to run through the other possibilities. Can I say for ch in other possibilities sub? No. For ch in other possibilities. I really don't want to do the I thing if I don't have to. Let's see. For possibility in other possibilities, we can do something like that. And I'm okay. So I'm saying instead of just getting the 1, I'm going to loop through them. If your character equals the first component, the character, then skip over the character and return that possibility. Okay, and I think this should be refactoring. It's a little bit speculative, but not really because we know what's coming. Okay, now I believe this thing could call twoCharacterToken with token dot slash. Well, it's float divide. Okay. And the rest. Okay, then we got to have some duples. One possibility is you see a slash, in which case you should be an int divide. Another possibility is you see an equals, in which you should be a token dot not equal. Okay. that I think should be a refactoring. All right, so should pass. Okay, now this, I'm going to inline slash operators. I did it kind of a sloppy way here, but we'll soon find out. Okay. The better way would have been to copy that up there, then delete that. We'll return that. Okay, and again, we'll see if that works. Okay, so we did make twoCharacter token handle a list of possibilities. And I don't know, would you call that a refactoring? It is in a way, but it's more functional than it started, I guess. So I don't know if you want to call it that or not. The existing code passes, so in that sense it's a refactoring, but we've definitely generalized it as well. It handles arbitrary numbers of pairs, not just one or two, but we haven't done anything that proves that. But if you got 0, 1, 2, you know, you kind of tested it. All right, so what was that leading up to? Well, we got to do bar greater. Okay, so bar is an error. Let's make this kind of like this. So bar is an error. Bar and bar greater. Okay, have I spelled them right? Bar greater. Okay. Now we need to add those to token. And I don't know, we got a lot of language things going on here. Bar, I guess. Bar by itself is an error. Bar greater. Okay. And these two tests should fail. Everything else should still be working. This first one should be okay because it's not expected now. Okay. Right. So we're at a failing test. Bar greater, bar both have errors. It's probably a good time for a quick break. So let's take 2 minutes, grab a drink, whatever, and we'll come back and get this thing passing. Should be pretty simple with what we just did in refactoring. So see you in a couple. Welcome back. All right. So let's take care of these tokens. Okay, we're matching on a single bar. Token. The first token expected token. The next one if we see bar, we expect token dot bar. And if we see greater, okay. All right, next one, less than, and less than bar. Okay, so we had some less than tests already, right? So we need token less than. Oops. And check token less than bar. Less than bar, less than. Okay. Now, these would have been work in our old system, but I think we can do them very straightforwardly with that other with that parameterized var args one we just did. So less than, and less than bar. All right, and these two tests should fail. All right, yep, okay. And less than bar. Should be pretty easy to add. Token dot less than, and token dot less than bar. Good. Then greater down here. Well, yep, okay. Add it to token. Where's my graders? Did I spell that the same? Greater than. Okay, should fail. Not equal to greater than. Yeah, so if we didn't parse it or tokenize it, we'd see one greater than and it'd come back the second time and ask for another one, but we want to get a single token out of it. So we're wanting the right thing. And where's greater than? Okay, and we'll just add another possibility, greater. That with a comma. Good. All right. Almost through. Okay. Now the minus. That one's a little more complicated. So basically, if you see a minus sign followed by, it can be followed by a greater than or a minus, in which case it's a token, or it's an end of line comment. So it's big enough we need a new routine to manage it. Let's add it. Where's we'll make another case like this. Test minus. Now, I don't think we didn't have a minus minus, right? We just had the single minus character. Okay. I don't think we do that already. Let's double check that. Minus arrow or end of line comment. If it's greater than, do nothing. If it's that, do nothing. Otherwise, expected minus after minus for end of line comment. Okay, well, that was kind of a temporary error because we knew there was a minus sign. So let's put the test in though. Token up minus. Okay. Don't think that exists. No. Up arrow. Where's the other arrow? Lambda. Case minus and case arrow. Okay. And this should fail with that message about minus after minus. Yeah, okay. So instead of a complaint, it should just return the minus sign. Okay, so here we'll return token, oh, come on. Token dot minus at starting location. And there may be another test that was expecting that was checking that case. Yeah, okay, so if it's greater than, we do that directly. If it's minus, we return the new line token, which we may just skip at some point. And otherwise, we return minus. All right. I predict our test we just wrote pass, but there may be another test that fails. And it's probably an incorrect test. Now. All right. Where are you? There we are. And did you return a minus? Yeah. Minus only returns error. That's no longer true. So we'll take that out. Okay. Good. All right. So minus standalone minus works. Right. All right. Now, oh gosh. All right, why am I whining inside? The way Elm works is these things by themselves. You can say A less than B, or you can say less than operator applied to A and B. And you need to know which one you're doing, and that means the left parenthesis thing, it needs to parse a token if it it sees the left parenthesis. It can't just say, okay, I got a left parenthesis, I'm a left parenthesis, a simple one character thing. Now we're saying you need to also look and see if you're an operator character, and if you are, then you need to be handling that. And if you're not, then yes, you're just a one character less than or parenthesis. Okay, so that's the single. That was infix operators. Let's tackle that. Infix operators. Okay, so we did all those. the standalone ones. All right. And I'll say infix up here too. All right. But we need to handle these others. And this is, we're getting back to functions because it's a functional language and everything's functions. But, the way you call these operators as functions is a legit way to do it. So we need to handle it somehow. We need to recognize these things. Wow. I'm not sure how I want to go about this. And one way would be parse the left parenthesis or look at the left parenthesis, go through this list of characters, less than, plus, ampersand, blah blah blah, all those things, and then call operator and get back an operator. Get back one of these little guys. And if you don't get one, you get a right parenthesis or a name or a whatever, then just return the left parenthesis. Ugh. Maybe we can put these off. I seem very willing to put things off, don't I? Okay, what else we got coming up here? So tokenized multi-character operators. The thing we haven't done is we don't have the notion of an operator. And maybe we should. I don't know. It's hard to know. I'm trying to get the easiest way to handle these things. I mean, I could just say operator characters and defer the evaluation of exactly which ones. That might be okay. So my match would be look for a less than, and then look for anything in the set leading characters, less than, greater, plus, blah, 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 blah. If you see those, if you see characters that can be operators, then you ought to take a string of them. Now, I don't know, there may be more complications coming. I'm kind of surprised how difficult it is to parse these things. I mean, the set is not chosen to be totally kind of orthogonal or anything. And if I had, I don't know. I think, some languages you can define operators and you can make strings of even like 3 or more letters to make them. I don't know. I think Swift allows that. In our case, we haven't done that in a very generalized way. And the other thing is, at some point, these things need to turn into functions. I mean, the prefix operators are really just the names of functions, and it should be treated that way. Okay. And if I don't do that, what we have on top is all this closure and function evaluation stuff. And that's a lot. Let's take a look at the syntax again. Okay, here's our syntax. Comments, literals, lists. We haven't done. Conditionals, we did something. Here's the operators. I mean, this is pretty minimal explanation, right, of what the operators are. But we went through, if you were here, we went through the Elm definitions, like the standard system library definitions, and that's where we got that list of operators. It's a shame they're not in some sort of real semantics. It may exist, and I just don't know where to find it. The other thing we could do, I mean, I don't know. I've been trying to go feature by feature, and we could tokenize everything and then deal with the features, because I can see there's more coming. I mean, like braces now, you do brace dash, and that makes a comment, but braces are perfectly fine characters in record definitions. And what the heck is okay? And we got square brackets. You can define arrays directly. I don't know if that got mentioned. I don't think it did. Yeah, I mean, it's just you keep finding more little syntactic elements. And it doesn't help any that I'm not that familiar with Elm, so I don't kind of know where the holes are going to be. Okay, here's these operators we did. I guess they mentioned the brackets because that's the list thing. Okay, so that's okay. Yeah, let's try and parse expressions. So it would be nice if we could parse a squared plus b squared. And we somewhere have a list of the precedents of all these operators, and there's a lot of them. I should have prepared more, I guess. Let me see. An old dragon book. I'm hoping the operator precedent stuff in here is interesting enough or straightforward enough to work off of. Yeah, so operator precedence is it's an old approach. So I would say, I don't know, I can't remember the years, but in the 1960s, it was definitely an approach. I had another book here. Well, I used to be into compilers and got rid of a bunch of books when I got out. So let me see. I somewhere might have Bill McKeeman, a compiler. Let's see what we got with him. Yeah, generator. I think ACM might have released this. Yeah, I definitely bought a copy. This is a programming language called XPL that was used as kind of a test bed for compilers back in the day. Okay, they published in 70. So I think they used the shift reduce operator precedence thing. So it's an old approach. So the early approaches, like the recursive descent was pretty early, and then this operator precedence, and then a bunch of other semi ad hoc methods. Fortran had this one where the original Fortran compiler, I believe, had this one where low precedence operators, you would substitute right paren plus left or something, to reflect the depth of its priority order. So they didn't have a good mechanism for precedence in those days, or, well, for whatever reason. But whoever was doing it this way, if you always replace a plus with a bunch of parentheses before and after it, you can enforce the order. So let me just sketch that out. Just a raw sketch here. So if you have 3 plus 4 times 5, all right, we want the times to have the precedence. So we would like it to be parenthesized, like interpreted like this, where 4 times 5 is done, not 3 plus 4 and then multiply. And the approach that they took, if I can simulate it, okay. So the approach they take is star goes to parenthesis star parenthesis, I think, and plus goes to parenthesis parenthesis plus parenthesis. At least for these two operators, this should work. And then you add on the ends. Okay, how many you need? All right, so if we take that substitution, and it's just a textual substitution, then 3, the plus turns into less than plus right. The for itself, and I'm going off line 10. Line 11 is our interpretation. I'll call it modern. I don't like that word, I guess, because it's like, you're going to be not modern soon enough. But anyway, 4 and then times star times 5. Okay. And then if you count, you can add one for, one for every left parenthesis and -1 for every right parenthesis. So as you go through, you go -1, -2, you need to add 2 parentheses. Okay, so we'll force those in. Okay, I don't know if I can bold these or anything. I can't even type. Bold. No, I can build. All right. So anyway, we know we needed 2 opening parentheses. -1, -2, -1, 0, +1 is 1, -1 is 0. Okay. But at any rate, we can tell we got we're down 1. Okay. So I'm not sure the algorithm on that part, but at any rate, what we should have now is a fully parenthesized version of our expression. And so you can see that we forced in parentheses more than we strictly needed, but they don't hurt, extra parentheses don't hurt anything. So we can evaluate the thing in its scope, and we never have to worry about operator precedence because we've always wrapped anything that might have had some, a lower precedence will be wrapped inside. Okay. So it's an old way of parsing. I mean, it gets through the, it gets through this challenge of how do you handle parentheses when you don't know what you're doing, basically, or how do you handle operators when you don't know, you don't have any mechanism for it. Let's see. So we're writing an Elm interpreter and we're writing code in Swift for it. So thanks for the question. Yeah, this thing is smart, for sure. I mean, I don't know. I learned about it a long time ago and it was like, whoa, before I learned any parsing, and it was like, oh, there's a way to do it now. And that's what they needed. And, they're writing the first one with this. I mean, there were calculators and some languages that were trying some stabs and things like that at the time, but, it's a nice little innovation. Let's see. Well, I have another old book. I don't know if you can see this one, is Programming Systems and Languages by Rosen. And it just goes through all these old, basically it's a historical survey of languages. So this is from 1967. So it's like the programming languages up till now, and it's still, an inch and a half thick. And there's another book by Gene Samet. I can't remember the name of that thing. Oh, let's try Gene Samet. Yeah, is that it? Okay, yeah, 69. So Programming Languages, History and Fundamentals. I think she's got several hundred languages in there, a good couple hundred. Yeah, 785 pages. So it's a non-trivial thing. And, if you think of 1970, that's literally more than 50 years ago at this point. And they had a lot of languages, a lot of stuff going on. But you had this very primitive parsing, and then you had people experimenting with this notion of operator precedence parsing. And let me see if I can do it. Okay, so one thing going on. This is a grammar approach. So, excuse me, it's a bottom up approach. So, I'm used to, like, my sort of go-to easy default is recursive descent. You define a grammar, you make sure it fits a few rules, and then you write procedure for each one, and boom, everything hangs together. The shift reduce is this kind of older style, and it's sort of bottom up in the sense that you start grabbing tokens, and as you pull some together, you realize, like, oh, hey, that's an expression, or hey, that's an if statement, or whatever. And now you've got the full set of tokens for them. So you sort of shifting is like pushing on the stack while you think about it, and reducing is when you say, oh, I realize now that's that rule. I can fold it in together and say, here's the rule. That's sort of the predecessor of all the bottom up methods, or at least a lot of them. And basically, let's see. Donald Knuth, another book of his, and I don't know when they started this series, The Art of Computer Programming, but it was probably either the 60s or 70s. I don't know. This one's from 98, so I've got second edition, volume 1, so 73, 68. Yeah, so he started this series in 68. Knuth was a real theorist and practitioner in parsing, and developed all the LR methods. So he kind of looked around at all these bottom up methods that were kicking around and generalized them into something that really matched the whole grammar completely and all that stuff. So a lot of bottom up methods, they might have a situation where they get an error and they can't detect it, which is never good. All right. Yeah, these books older than you. Yeah, unfortunately, they're about my age. But, it's there's some good stuff. I mean, there's another nice book that's modern. I can't remember who wrote it even. But a very nice book on grammars and modern approaches to grammars. And there's like PEG grammars and a bunch of newish kind of things. It's by another algorithm person, but there's a few books on parsing that are out there that kind of try and catalog all these approaches. But there are dozens and dozens and dozens. I mean, probably, I don't know, maybe one per language. Who knows? But there are tons. I mean, we could probably do a quick research and find 10 or 15 easily, and then there's bunches of others. So you got these choices. Well, the one I'm looking at for us is operator precedence. And what operator precedence does, it doesn't take this approach. This, I think, is the original Fortran, I think. Okay. The next approach that I'm looking at, well, we have this top-down recursive descent approach, and basically the grammars we're doing. Let me bring up our grammar, and you can see bits of it. It ends up mucked up with all the error handling and stuff, but the basics of it are really pretty simple. But so you do a parse. And basically it says, if you can start an expression, because we're mostly handling expressions, then do a function call or definition. Well, here we call a method called expressions. And so basically we either consume tokens like this, or we call something that's going to look for things. Okay, and this is why it's top down. We started off with a function call or definition. We said, look for some expressions, then look for an equal sign, then look for more expressions, and all that. Okay. It can parse our expressions, but the problem I have, or the concern I have, is that if we want to get all these operator precedence things right, we have to have a grammar that has a layer for every operator precedence. And I think we found out there were 10 levels the other day in going through those files. Um, you know, and that's that's just a lot. And I feel like, oh, could I get something better? And what I would like to do, this notion of operator precedence, that this is what we're using, match tokens or call methods that find things top down. Okay. The operator precedence method, it's kind of taking, like, I think of it as the generalization of your grammar school rules that say, PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. And then if you, apply the operators in that order, it's okay. And so what you do, let's see if I can, I don't know if it's worth putting this in, but just to kind of quickly do it. So you got nothing. All right, up here, we're going to make a table, and it's like this: id plus times, and then dollar meaning end of file. Okay, and then I'll just make a line here. Okay, and then we do the same thing going down: id plus times dollar. Okay, and then we're just going to say, are you less than or greater than, what's your precedence? Is it less than, the same, or greater? Okay, so id to itself, that just doesn't happen because we don't say 3, 4. We don't have implicit multiply. Okay, so we'll leave that one blank. I'm going to write greater, but it usually they put it's a funky little greater. And greater. Okay. And this one is less. Actually, the whole column is less. And hopefully I'll make sense of this enough to get us going here. So anyway, my theory of what we might do is, if you had something that could produce this table given the precedence levels, this one's 3 graders. If I had something that could automatically look at my 10 levels and build a table like this for me, then, less than, greater, less than, greater. Okay, I guess I got to type and not talk at the same time. Sorry. Less than, greater, greater, greater. Less than, and nothing. Okay. So the idea with this table is we're trying to imitate our grade school understanding of what precedes what in terms of operators. Okay. And my thought is that we would do some sort of top-down match to get all the pieces, and then do an analysis based on this to parse them according to their precedence. And that would let us define our top-down grammar to be one level. Just look for a variable operator, a variable or variable followed by operator and another variable, and repeating as many times as you want. The precedence comes in. Let's see if I can do this. Okay, so I want to do something if I see plus versus less than. Yeah, so if you get plus in this column and less than in this column, I think what that's saying is plus has lower priority than greater, than star. Okay, and a star has greater. Is that working? Like I said, I'd been better off if I'd prepped this a little more, but you're seeing me research it real time, I guess. And so what you do is you basically you take your string. Let's take it down here, and we'll put a $sign on both ends, I guess. So $sign is less than id, we'll take a number for id, 3 greater than plus greater than star, or sorry, less than 4 greater than star, less than 5 greater than dollar. Okay, and this is where the less thans are they're really these weirdo less thans and greater thans that are in the table. And so you can use the table to kind of insert these as precedence relationships, and then you look for the first greater than, and then you go back until you find a less than. So you're sort of trying to find the matches of greater with a less than, and it's kind of a back and forthy kind of thing. But if you do these, okay, you skip backwards, and the handle is the less than 3 at that point. So you have this handle, and then let's see. Well, I've got a whole algorithm. I guess I should be pulling that in at some point. But basically, you're using these graders and less thans to kind of tell you like which pieces have to be done separately, and seeing seeing these pairs, you can get them. But I don't know. I'm gonna have to. I'm just going to have to dig in on this algorithm and see if I can make sense of it. But maybe I'll do that. I don't know. I never know whether it's better to just go ahead and do everything I'm doing and you see all the research. But my fear is sometimes that's like, oh, that's kind of boring to watch somebody read. But there is an algorithm, and I think we can apply the algorithm. I don't know. We'd have to build the table first, though. And so there's an algorithm to build the table. And maybe that's almost like a little sub project. That's probably a couple sessions to take the operators and build this table. But in effect, this is what you get when you allow user-defined precedence levels, which Elm used to do, and they took it out. But in their system, they still allow it in their system definitions. So the system is allowed to do that. You as a user of the language aren't, which is okay. I mean, it's, got to make restrictions to make progress, right? But I think what this gives us is if we take the precedence levels they gave us and we applied this method, then I think we could get the parsing. The actual parsing would be very simple. This matching would be super simple. Just find these tokens and get the string of them and do what it says. But my fear is, because we've got operators in there too, because it's certainly legit to type 3 plus, factorial of 4, right? I mean, if factorial is a defined function. So I don't know. I don't feel like writing, this is it. I don't feel like writing 11 levels of grammar to handle all these possible cases. And writing my parsers and all that for 11 levels deep. So my proposal is, let's spend 2 days or more producing the precedence table and then applying that. And I don't know. Am I boring or not? It's like, am I doing this the hard way and wasting time? Yes, this operator table is static. So yeah, we would generate that once. It would almost be, and I think that's where McKeeman and all had the compiler generator idea. I think they may have generated these tables automatically or something. I don't remember. It's been a long time since I looked at that book. Well, I guess 5 years we saw since I bought it. So where it is, I don't know. But yeah, so we would generate this static table and kind of feed it into our parser, and there would be a stage after we parsed it, which would be very simple, just like match tokens with operators and keep going until you find something that can't be an expression. That would be a very simple parser, and then we would plug in this table and say, okay, now analyze this, turn it into a parse tree that reflects the precedence. I think that would work. I don't know if it's the best way, the fastest way, I should say, for us to get there or not. I really hate the idea of just plunging through multiple levels of the grammar, but maybe that's the easiest. Maybe there's a way to combine it. Like if you were willing to look up the operator, I mean, the other way I think of it, it's almost like, well, what we have on those, I think he did something like this. He would say infix plus precedence level is 7. Infix times precedence level is 6. And then, I don't know, maybe infix exponent. Exponent is precedence 1 or something. Highest precedence. I don't know which way is high and low, but, if you would list them in order, and this was a right precedence, which complicates things too. You get a table like that, and maybe there's some way to integrate that table in with the parsing. That may be the best. If you could look up a character. Yeah, what if you were doing the parsing? Okay. Make another experiment here. I mean, the rule is going to be something like this. We had function def, or we had expression or function def, something like that, and it went to expressions and then optional equals more expressions. So if it's a definition, it's going to have the equal sign, and if not, it won't. And then our expressions rule is things like, well, right now it's things like number, or it could be a number, or it could be a parenthesized expression. Or other things, I mean, it could be a name, a lowercase name, or an uppercase name. Okay. Now, what we want to do is we're trying to say that an expression could be those things, basically all those things, maybe followed by an operator and another expression or something like that. I mean, we have to make sure it's not left recursive, but I think that's legit. So the quoted parentheses operator, this operator expression is following it, and you could have this more than one time, many times, 0 or more times. So that would, like, we could take 0 number 3 plus 4 is number plus 5, and so on. And we would get a tree out of that, and maybe we could get a very broad tree. But once we had that tree and said, this is an expression, okay, parse it. But I wonder if instead here, when I do operator expression, can I somehow know whether to consolidate what I have or, defer it? I mean, there's got to be a way, knowing that precedence. Okay, again, I'm not sure which way to go. I guess that's apparent. All right, I think what we'll do, we'll take a 2-minute break. We'll come back, pick a direction, and start moving. That'll be it, the way to go. All right, so see you in a couple minutes. Okay, welcome back. What I did was a quick search, for various parsing things with recursive descent. And I don't know, maybe I should just bite the bullet, do the 10 layers, and call it a wrap. Maybe we don't need all 10 layers to be interesting enough to do things. But this is the PEG grammars, parsing expression grammars. And they're kind of, they're similar to top-down parsers like recursive descent. Let's see. So what do they do? It's something like I think they give the OR bar a priority, so you can sort of force an earlier path. Um, but I'm not gonna. Okay, well here's an example. Some product plus product. Well, okay, this is an example of a grammar that it's a grammar for simple expressions, but notice this power goes to value to power. It's trying to get the right precedence going. This one, product plus or minus product star. That's kind of like I was talking about before. Um, so they've built it into the grammar rules as to how it works. I don't think it gives us any extra power then. Um, Pigs are more powerful but require significantly more memory. Okay, well, I don't have to do memoization. Okay, it's a moderately complicated thing. Okay, with that we saw. Yeah, I don't think that's going to tell us anything. No. Okay, operator precedence. Yeah, here's the algorithm basically. So the thing is, you've got this look ahead, you know the precedence level, and you're deciding whether to push things on or take them off basically. Um, I don't know. Oh yeah, here they mentioned that thing I was talking about. Fortran 1. Okay, so I was recalling that right. Replace these with 2, replace these with 1, and add left parentheses at the beginning and after each original parenthesis. Okay. Yeah. Okay. Well, interesting but not particularly helpful. Implementing a substituting from recursive descent. Well, I think that's moderately what we're doing. Okay, yeah, so in this grammar, expression goes to expression, operator expression, or it's a unary. It's an ambiguous grammar. We don't know which expression to parse first. When you got like 3 plus 4 plus 5, do you put 3 plus 4 here and the 5 here, or is it 3 plus 4 plus 5? Okay, so it is ambiguous. You got these operators. I mean, basically, they're going to have to draw them into levels. Expression operator pending. That's interesting. No, that's like the wrong way. Okay. Not much of a write-up. Okay. Oh. So, let's see. I guess what we would like to do. Boy. So I think the story is expression with operators. And maybe there's something we can do. Like if we somehow encoded the priority in these things, you would think that would help somehow. Okay. Let's see. So what did we accomplish in Lexerland? I didn't check that last thing in. Okay, let's diff this. Minus. Okay, so let's tokens support standalone minus. Okay. Well, here's an Elm question. this. If I have 2 to the 3 to the 4, 2 to the 3 to the 4, or 2 to the 3 to the 4. Yeah. Okay, so the default precedence is rightmost precedence in Elm. So 2 to the 3 to the 4th is 2 to the 3 to the 4th. But 2, well, it's 10 minus 3 minus, or 4 minus, whatever I bumped, minus 2, and 10 minus 4 minus 2. Is that, whoops. Have I chosen bad numbers? Looks like I have. How about 10 minus 7 minus 1 is 10 minus 8. 10 minus, yeah. Okay, so you got left precedence on plus and minus, and right precedence on the other. Okay. Wow. My fear is I'm going to muck up our grammar trying to figure this out. Now this, it just calls everything with a bunch of expressions an expression. All right, let's take another one. Let f equal lambda x goes to x times 2, 3. Whoops. The in keyword. Oh, no let. F equals lambda x goes to x times 3. All right. Now if I do f of 3 plus 2, am I doing the 5? Or am I doing f of 5, which would be 15? Or am I doing f of 3, which would be 3 times 3 plus 2 is 11? Okay, I'm doing that with 3. So what that tells me is knowing the type of f takes one argument and it's a number. It stops there. All right, and let's just make sure f of 3 plus 2 is different. We know it is, but okay. So I can't just parse these strings of stuff and say, oh, you're obviously an operator. You should evaluate. The function evaluation, how many parameters it takes and stuff like that. Well, I guess it knows. Okay, let's make a new function. Let's g of x and y equals x minus y. Okay, so if I call g of 3 plus 2 and 7, doesn't like it. G of 3 produces a number. Okay. It produces a function that returns a number. So we have this automatic currying thing where when you call a multi-argument function, it really is you can just call the first argument and still get the rest of the function. Okay, so it knows function call has priority over operators. Well, that's interesting. Okay. Trying to think what would be a useful way to go with this. Okay, so the way it is now, when we get expressions, we accumulate a function call with a list of expressions. All right, so while we can start an expression, append. Now our expressions, they're very flat. You can be int, float, names, parenthesized expression, lambda expressions, if expressions, and variables. I'm not sure why variable is not lowercase name. I think that probably is. Yeah. That's a little redundant. Okay. And if you reference a name, you could either be a variable like x equals 3, or you could be a function like our f or g. All right, now this, like, we would like to get our operators in there. I mean, it should be legit. Going back to Elm REPL. Okay. We had f takes a number. I can say, well, I said f of 3 plus 2, but I didn't do the other one. I could also say f of 3 plus 2. That should work. F of 3 is 9. Well, I'll make it plus 21. How's that? It's 21. Okay, so that is fine, but f of 3 plus 21 is not. Oh, it is. Whoa. F of 3 plus 21 is... What did it complain about? Oh, nothing. It just applied the 3 first. F of 3 is 9. Okay. So f... Let's try g of 3, 2 plus 7. G of 3 and 2. I think, well, okay, g of 3, 2 plus 7 should be different. Yeah. So it looks like the function is saying, I expect to see 2 arguments. And the g3, 2 plus 7, g of 3, 2 plus 7, it really is treating that as g of 3, 2 plus 7. Okay. Wow. This is going to take some thinking. Interesting. They spend so much time on that Fortran method here. They give you an example C program and everything. Okay. I don't think we can do that. Produce. I don't remember this one. Top-down operator precedence. Well, that sounds like what we're trying to do. What's the programming languages? I don't know if I have that. Come on, you can do it. Profit or commercial advantage. Well, I don't think I'm doing that. But I'll let that be. Okay. So if we parse parenthesized. Oh, hello, welcome. Let's see. Oof. I think what it's coming to is my function call has to know how many arguments it wants. Maybe that's the restriction I'm hitting. And maybe it doesn't matter if I... Well, okay, so I've got the expressions. Okay. I really feel like I'm stumbling around, so welcome to watching me stumble around. So this is all true. Like, expressions can do these things. That's fine. Inside parentheses, they can do operators. They can do it standalone, but they can't do it as an argument to a function. And I'm not sure how we're going to enforce that unless we... I mean, maybe this has to be more sophisticated. When it sees a lowercase name, that has to be either a constant or a function. Well, it's a constant. Well, it's not a constant. It's the name of a constant, or it's the name of a function. Either one is kind of a constant, right? Because the function isn't changing while we parse it or anything. We know the precedent or the number of arguments for that function. So I think maybe what that needs to do, maybe the semantics has to be in here. Like, is this a variable? Well, if you said f equals lambda n blah, 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 it's a variable that happens to be a function. So when you evaluate it, well, when you say, what's the type of this variable? If it's a constant, you just return the variable. Well, is that right? I want to say, if you're a function, I ought to be looking you up and seeing how many arguments you have and consuming them as part of this. So we had our f of 3. I really would like to know that you're a function. So maybe that needs to expand. Maybe this is lowercase name expression star, where the star is repeated not arbitrary numbers of times, but it looks up the function and says, how many do you want? And if it's a constant, it says, I don't want any. If it's a one argument function, it says 1, and so on. But if you only have 1, if you need 2 and you only have 1, that's allowed. You're allowed to curry it. So I can't force you to have more than you have, but I guess I could have at most the number you have. I don't know if that's... Like, we got our symbol table somewhere. Let's find that thing. Well, I got the Boolean type, predefined custom types. All I have so far is this. False and bool stuck in there. But at some level, I would like plus to be a function that applies to 2 arguments, because I can say this. I can say plus 2. I can say let f equals plus 2. And that, whoops. Oh, I keep saying let. H equals plus, well, let's use minus because you can tell if it applied. 3. Okay, so if we take h of 1, do we get 2? Yeah, so it's really saying I'm 3 minus, and then you plug in the 1 and you get 2 back, because 3 minus 1 is 2. Okay, but we could have also said h equals minus 3, 1, and gotten 2 back. And that's the value for h at that point. Fully specified. Well, let's see what minus is by itself. So yeah, you look that up, and it takes a number and produces a number. But because of the currying effect, you can just give it one argument. So I can't force it to read 2 arguments. I could allow it to read up to 2 arguments, and if they're there, then yeah, they're legitimate arguments to this thing. I'm going to get fancier. Can I do minus of 3? That's a function. Let's see. Minus 3 is a function from number to number. And if I apply that to 2, I get 1 back. Yeah. But I don't. No, that's okay. All right. But if I'm doing that, looking at this lowercase name, I've got to look up its type. I can't. Okay, I'm going to get more complicated again here. So if I assign, let's see, h equals foo of 3. Can I do that? No. Because it doesn't know what foo is. Okay, that's a good thing for us. That means we really do need to know the value or the thing at that point. So some definition has already happened. Maybe it's a system definition. Okay, so I think what we're going to say is our grammar should be expression star, but this thing, it's got a footnote. And footnote 1 you can have at 0 to as many arguments as this function has. Okay, so this is not pure parsing. This is saying I'm going to look up this name, and if it tells me it's a 2-argument function, I'm going to try and parse 2 expressions. If I only see 1, that's fine. And we have can start expression, so we can tell if it's another expression there. And a plus does not start an expression, or another does a minus or an exponent or any operator, I don't think. We may have some complications around -3 or something, but okay. So I think that's what we want to say is if you parse an expression that's a lowercase name with a definition, we expect to parse more expressions here. And you sort of get priority, right? Because this thing is calling multiple expressions, but you get a priority. Okay. I don't know. I may be digging a hole here. All right. Well, it's 3 o'clock, so we're going to call it a wrap. We'll pick up here tomorrow morning, 9 to 11:30 a.m. Eastern time. And I think I will make this this extended expression evaluation function call thing, make that the priority. I may do some reading up on operator precedence or some other method, and we may go down a different path. But as of right now, I think that's what I'll do. So thanks for joining me today. Hope we can go in the future again, and I'll take care, and I'll see you later. Bye-bye.